Welcome to Open Source Spotlight. We invite open source authors and ask them to show the tools they're working on. Today we have Andrey. It's not the first time we have Andrey. So Andrey already came 8 months ago to show the tool he was working on. And today he will show again the same tool and some updates. But first, hi Andrey, and please tell us a few words about yourself and a few words about the tool that you want to show us for those who did not see the previous demo.
Hi Alexei, very glad to be here again. My name is Andrey. I'm the founder of dstack, the open source tool that simplifies running ML workflows in the cloud. And today I'll be giving you an overview of what dstack is for those who haven't seen the previous one, and also will tell what interesting we are working on, and we'll probably do also a demo.
Yeah, I'm excited to see it.
Awesome. Okay, awesome. It's been a while. Probably we talked last time several months ago, and that was soon after we've open sourced dstack. So it's been a while now, but we are still on the journey to simplify running ML workflows in the cloud. And yeah, since then we've done a lot to improve the developer experience, and to start with, I'll tell you a bit in general about what we try to do. So if you think when you work on ML, there are three typical workflows, let's say. One is dev environments. We typically need either an IDE or a Jupyter notebook set up with some dependencies and all ready for interactive work. And this is what we need when we, let's say, explore data, play with the model, and then try to come up with some solution before we can, I don't know, start fine-tuning it or deploy it to server. So that's one thing. Secondly, once you've come up already with something, you can try to run certain workflow as a long-term, long-running job. Like, for example, you want to fine-tune a model, or you want to pre-train model. So basically this, especially for large language models, this takes some time, and you probably want to run the script and then monitor it from time to time and wait until it's finished. And secondly, of course, once you have a model, you may want to serve it and expose it either as an API or as an application. So these are three general types of workloads. And especially now with LLMs require high-end infrastructure, which we often don't have locally on our laptops. That's why we typically need either some remote capabilities or some cloud capabilities in order to either develop ML or to train models or to serve them. And dstack solves this exact issue. So how it works is it allows you to declaratively define your thing, like be it a dev environment or be it a training or serving task as code. So for example, here you can see an example of such a, let me see. So here's a YAML file that defines a dev environment. So I have some dependencies here. I specify which kind of dev environment, which ID I want to use for that dev environment. Or here's another example for serving. I may specify again the dependencies I may want to install, and then how to run this particular task. In this particular case, this is a serving task for serving my Gradio application. And once you've defined this, then you can run it. And for example, you can specify this particular configuration file, and then it's what it will do. It will prompt you to confirm. So it already has certain configuration, which clouds you may want to use, and then it will pick up some cloud instance that fits the requirements, And then all you need to do is to say yes, and then it will automatically provision that particular cloud infrastructure to run this thing, and you'll be monitoring that. And once, for example, this application is up, it will forward the ports to your local machine for secure and convenient access. Like, but let's go step by step to see how it works. First of all, before you come up with some configurations, typically you start with defining such thing as profiles. You may want to use different cloud providers, and even within one particular cloud provider, you may want to use different, let's say, types of instances. So dstack helps you kind of manage it through profiles. For example, here I have a profile called Lambda, where I specify that I'm using the Lambda project. Yeah, so here we have a profile called Lambda, where we specify the project name Lambda, which is configured with dstack to use our Lambda cloud account. And then we have this resources definition where we say, okay, for this profile, we need a GPU with at least of 24 gigabytes of memory, and then 28 gigabytes of RAM. And please make this profile default. But you can also configure other profiles, and then later you can switch between them easily when you run things. So once you've configured that profile, we can proceed to defining our let's say configurations, and let's start with the most simple one. This is a dev environment configuration. All we say here is that we want to use VS Code. Here's our dependencies, and then we run it. Let's say we run it this way. It just finds the default .dstack.yaml configuration. Tell us that, yeah, it will use our Lambda cloud account, and it will create this instance with A10G GPU, for example. I can confirm, and then it will take a couple of minutes to provision it automatically and run this dev environment. So here we go. I just a couple of minutes ago actually just ran it, and once it's up, and then it gives us a URL that we can click to access that dev environment. So let's try to do it. And here you can notice that it works through there. Here in particular, it uses the VS Code integration. So it already configured the secure tunnel to our dev environment. All we need to do is just click that URL, and it automatically connects to that dev environment using our desktop IDE, where we already have that particular Git repository with all the local changes set up and ready, so we can continue work. But now we actually running on a cloud instance, and we don't have to worry about dependencies because, well, dstack installed them automatically for us. And we can just make sure that all we need is here NVIDIA SME. Let's see what GPU we have here. Right, so everything is correct. We have NVIDIA A10 here. Right, and we can also see that it has, let's see if we have Gradio here. Yeah, we do. So just to prove that all the requirements are installed. So now we can proceed, for example, and let's say, yeah, just go ahead. And for example, in this particular case, we would like to continue working with the repository in our cloud dev environment. Let's say we want to run this this application. By the way, we are using very cool repo created originally by Park Chanson, which is called LLM Chatbot as a service. This is a very cool Gradio application. We can just run it right away. By the way, now we So it says local host, but don't be confused. We are running in a cloud dev environment. It's just that dstack and through VS Code integration automatically forwarded the port here. And this application is very cool, by the way, if you've never seen it yet. It allows you, well, no, we're not using our own model. So it allows us to chat with any of their open source LLMs. Like, for example, let's say, what do we have here? Quite a few LLMs. So let's say we want to use Falcon. We can configure it. We can confirm. Now it will download this pre-trained model, which takes roughly 10 seconds or so. And then it will open the gradual application. But again, we have no purpose here to delve into chatbots, but this is just a way to show how you typically work with the dev environments. Again, let's say we want to get back to the dev environment. Let me somehow stop it. Yep. Then we can also, for example, run it as a Gradio app, and then it will enable automatically that live reloading feature of Gradio. So we'll be working with this cloud environment and we'll edit, debug our Gradio application as we want. So that's one thing. Let's close it so far. But it works the same way with other types of configurations. I've just shown you how dev environments work, but you can also run trainings the same way, or serve applications. This is an example of how to serve the application, which makes it very convenient for you to abstract out of a particular vendor, cloud vendor, and have these configurations defined declaratively as code within your repo, and then on demand be able to run any of them conveniently, and what is even more important, cost effectively. So why it is cost effective? So there are a couple of important points here. So one is, with dstack, you are not bound to one particular vendor, which means that you can switch between vendors and, for example, use effectively spot instances if you want. Like, for example, with profiles, you can configure whether you want to use spot instances or not. And then you can also switch between different regions and between different cloud providers to find the best availability and cost. And also, you might, for example, use such GPU providers as Lambda Cloud, which, as we know, offers a lot cheaper GPU. So in a way, basically, you reduce your dependency on a particular vendor and just make it easier for you to produce stuff. Right. And last time we spoke, we only supported AWS, and we only allowed you to run, let's say, tasks, like we used to call them ML workflows. And a lot of things has changed since then. And let me just go through the main changes since then. Like first thing is, we've improved the dev environment support. So now, as you've seen, we support desktop IDEs. If previously we ran this web-based VS Code or Jupyter notebooks, now we prefer to offer desktop IDs simply because it's a lot more convenient. I have my shortcuts configured. I have all the themes and other plugins set up, and now it's very easy to use all of that to work with cloud dev environments, regardless whether it's Lambda Labs or whether it's AWS or GCP. And here I would like to also use this chance as a, to advertise VS Code actually for remote development, and not just VS Code, I guess IDEs in general. I also ranted about it on LinkedIn. there are quite a few people that are very much used to using Jupyter notebooks. And as we know, Jupyter notebooks are very great tools for interactive work with data. However, not a lot of people understand how great today the Jupyter notebook support within the modern IDEs. That's why it really makes sense to use IDEs for your ML development in the first hand. Like for example, with let's say with no, sorry. Let me just show it how it works. So I create this Jupyter notebook within my dev environment. It automatically asks me to let me switch to our cloud dev environment back, and then here what you'll do is create a Jupyter notebook just to show you that you can actually use Jupyter notebooks from an IDE with even better experience. That's just a, I'm sorry, it's just IPyKernel. Okay. So here we can manipulate these notebook cells. We can visualize cell outputs same ways as we typically do with the Jupyter notebooks. And we also can switch very smoothly between notebooks and Python code, which is very important because especially when you work with ML, eventually you want to migrate all, well, most important pieces of your code to Python files, Python scripts, and then commit it to Git. Yeah, that's just an example. But so that's one area of improvement where we try to improve the developer experience. Second is, well, originally we supported only AWS. Now we support also GCP and Azure. And now basically this week we hope to release their support for Lambda Labs, which is a very big deal. And a lot of people are pretty excited about that and asked us about this because with the GPU prices that Lambda Labs offer, well, you can do a lot more. Especially now with LLMs, right? And yeah, that's mostly it. But we keep on improving the developer experience. So our main purpose is to make it very easy to run any ML workloads, so you don't have to worry about costs. So we kind of optimize it for you. But then also you don't have to think of don't have to do manual work. Like for example, typically when you work with some cloud vendor, especially for this kind of workloads, you very often have to use SSH. Basically, you create an instance manually, you go there, and then, well, you wait some time, but then you SSH there, and then you install the dependencies, and then you run something, but then you have to wait. Every time you have to repeat these manual steps, which results in a lot of manual work, but it also may results in having certain instances running, even though that you don't really need them, which can, if you optimize that, you can also save a lot of costs. And one area where we work right now to make it even more convenient, this is in our roadmap, is making it easier to run applications and APIs for LLMs in the cloud easier.
You already answered some of the questions I prepared in advance, like your plans.
Sorry about that.
Yeah, that's fine. So you mentioned that there are three sorts of workflows, like the development one, the one you just showed us. Then there is long-running jobs for fine-tuning, pre-training, which is like when you have some sort of a training pipeline and you run these jobs on the cloud, and then the serving one. So here, what you showed us was the dev environment, dev workflow, and a bit of serving. I think at the beginning you showed serving, right? And when it comes to long-running jobs, I think this is what you demoed last time in the previous demo. And I'm wondering, so in the previous demo, you showed that to us, like how to run a job. Did many things change since then in the interface, or we can just go ahead, watch this demo, and everything from that demo will still work today?
Right, very good one. We had to change quite a few things, not maybe fundamentally, but in terms of the user interface. We are still using YAML as a general interface for defining workloads, but we changed the format significantly since then. If previously we used to have one global workflows file where you could define these workloads. Today we just want to make it a bit easier to define them. Like, for example, one thing, you may want to define them in separate files. That's one thing. Secondly, often we also hear that people want to define these configurations next to the code, not in a magical folder, but next to the code. And you might have multiple folders, one for serving, one for training, one for something else, and then you might want to put these configurations there. We used to have this low-level abstraction called provider, which allowed you to either run a dev environment or something else. And we rethought that to make it more high level. And that's why we introduced these types of configurations. Now we have dev environment configuration, we have a task configuration, and probably will continue making it even more convenient. So we'll see how the interface might change when we improve the serving capabilities. To reflect these changes, we've also adjusted the dstack run command. So if previously you had to give it a name of the workflow you want to run, today you give it the working directory, and then by default it tries to find the configuration, or you can specify a particular configuration here, which makes it just more a bit more versatile and more flexible. There's another thing which has changed since then, which is also quite important. Previously, last time we spoke, it was just the CLI and you just define this workflow and then you run it. Today, you always have to keep either locally or on a dedicated server, a dstack server started and then running. You typically start it with this dstack start command. And it also has the user interface where you can configure multiple cloud providers. We call them projects. Then you can also invite people and create tokens for them so they can securely access the dstack platform. And then also within this, within this projects, you might also monitor different runs and also manage them from the interface. But in addition to just managing projects and users, dstack server also provides this advanced orchestration capabilities. Imagine that you've submitted a run that for example, is using spot instances. And there is, for example, right now, no spot instances available. So dstack server will keep on monitoring for that availability of that spot instance. And as long as it is there, it will submit the run again for you. So you don't have to worry about that yourself. So that's another improvement.
Yeah, it's pretty amazing progress, I must say. For 8 months, you have done so many things. That's mind-blowing.
Thank you.
Yeah, I don't remember how many people you said were working on the project right now, but I imagine right now it's more than it used to be, right?
We're still a small team, but it's a good point. It's really hard to remember how many we were. I guess we've grown, but we're still a small team. So right now we are 4 engineers working on the project. And
yeah,
sorry.
Yeah, I was just asking if you plan to take part in any open source activities like, well, I guess it's late for Google Summer of Code, but maybe for Hacktoberfest this year?
Absolutely. Yeah, this is all we do is an open source, and it's a great idea actually. We have some small contributions, but we certainly would like to have more. And also we've just recently opened the developer advocacy internship position. And so interested in having one or several people helping us also spread the word and then create meaningful examples to help the community build using dstack.
Yeah, you have an amazing talent of answering questions before I ask them, because that was another one, like how people can contribute. Maybe the next one, I will ask it explicitly. If you have any advice to anyone who is watching this?
Just yeah, put aside all your work and then give it a try.
Okay.
Jokes aside, well, I mean, what can I say? We are living in a interesting time. So much happening right now with LLMs, and what I'm especially quite amazed by is the open source life. So many new things appear pretty much. I mean, maybe not every day, but certainly every week. And there are new LLMs. There are new frameworks that make it easier or faster to run LLMs. And I'm quite surprised and very happy about the development, because there are people that are pretty, like they say, ChatGPT is, figuring this out for everyone. But we see a lot of open source models appearing, and every new model improves significantly. So yeah, pretty amazed by the progress.
I think just today I saw posts on LinkedIn and Twitter saying that there is a new open source model from, I think, Hugging Face that beats GPT 3.5 for chat tasks. So yeah, that's amazing.
Totally. And then the best part is that with these open source models, especially now with vendors such as Lambda Labs, for example, it's pretty affordable to give a try to them and then see how they work, and then play with them, not just read news, but also actually engage in using them.
Yeah, right. So I don't need to have a cluster of GPUs to try that at home, right? Not at home, but like...
For sure. Yeah, especially for smaller models. And then yeah, you can already and which is great. What is great is that there are different models, and then you can also try to find some model, or maybe fine tune it or adjust it to do something specific. So that's why you can also explore the utility of smaller models.
Yeah, thank you, Andrey. It's amazing to have you here. I'm really excited to see what happens next for you in the next 8 months. I'm pretty sure it will be something as amazing as this one. So I'm looking forward to seeing you doing a demo one more time, maybe in the future. So thanks for dropping by.
Thank you, Alexey. Looking forward to it.
So speak soon.